Hello and welcome back to Boxers Shorts, where we take difficult ideas from GCSEs in science and we try and do little videos where we've explained what's going on and give you an opportunity to practice. A reminder before we even get started, unless you're using your phone for this video, your phone should be away. If you're using a laptop or a desktop, your tabs should be closed, no distractions. Today we are going to be doing the first lesson in the chemical change unit. The chemical change unit covers the reactivity of metals. It also covers acids and alkalis, and it also covers electrolysis. But what we're going to be doing today is deducing ionic formulae, which is a skill that you need for all three of those. So you need it for chemical change, for reactivity of metals, for acids and alkalis, and for electrolysis. So whichever one of those three you are currently studying, this is the first video. We're going to start with some questions, and I remind you, before I show you the questions, I remind you that I'm going to be giving you lots of questions and activities and exercises to do in these videos. If you don't do them, obviously that's your choice. I can't force you to, but you are probably wasting your time watching these videos if you are not going to do the activities. So I'd like you to start by having a go at these questions. You're going to do these questions on a piece of paper or in an exercise book or whatever, and then you're going to resume the video. Please pause the video now. Okay, you should only be listening to my voice if you have if you've done these activities. And again, I remind you, if you've not done them, you are wasting your time. So let's start with 2 atoms of lithium. Now, I'm not going to go over in great detail how we draw these because you should know them from the very first unit that you've studied. I'm going to start with lithium. Li. I know that lithium has 3 electrons, which means 2 in its first shell and 1 in its second shell. Oh, what am I doing? Sorry, that should be a cross. And 1 in its second shell. Now the question says to draw 2 atoms of lithium. Now if you were so lazy that you just drew one and said, no, I can't be bothered to do the other one, obviously that's your choice. But again, like I said before, you're wasting your time. Here's another lithium. Like that. Now, the next question says to draw 1 atom of oxygen. Now, at this point, I am going to use dots instead of crosses. I know the symbol for oxygen is O. I know that it's got 2 electrons in the first shell, and I know that it's got 6 electrons in its second shell. The question says to show what happens to the electrons when 2 atoms of lithium bond to 1 atom of oxygen. So I can see that oxygen has 6 electrons in the outer shell. How many electrons does it need in the outer shell? Call out your answer on 3. How many electrons does it need in the outer shell? 1, 2, 3. I'm hoping you said 8. Now look at my lithiums. So what I could do is, just to make that really explicit, I'll write that this needs 8 in the outer shell. Now these lithiums, right, they've got 1 electron in the outer shell. Are they going to lose or gain electrons? Call out your answers to screen on 3. Are they going to lose or gain electrons? 1, 2, 3. I hope that you said they will both lose an electron. They'll both lose 1 electron, and that will give them a full outer shell, which in these cases would be 2. So they need 2 in their outer shell, because that'll be the first one. So they're going to lose 2. Sorry, each one is going to lose 1. So I'll write each will lose 1 electron. This needs 8 in the outer shell. Well, it's got 6, so it's going to take 1 from there and 1 from there. And then it will be happy and have 8 electrons in the outer shell. Now, question 4 here says, explain why the formula of lithium oxide is Li2O and not LiO. Now, I'm hoping that by looking at this diagram, you can tell why that's the case. If I only had 1 of these lithiums, so I could only give the oxygen 1 electron, it wouldn't have 8 in the outer shell. It would have 1, 2, 3, 4, 5, 6, and then only 7, including the one from this one. So I need 2 lithiums here to be able to give those extra electrons so that the oxygen can now have 8 in the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. Happy days. So the formula here is Li2O, which means it's got 2 lithiums and 1 oxygen. Let's move on. What this leaves us with is a situation where I know that lithium oxide is Li2O, and I know that it's not LiO. You will often be given words like this, sodium fluoride, and be asked to predict the formulae of them. And what I'd like to do is to show you how we do that, or how I do that. Now, the problem is you don't want to have to draw out all of this every single time. What you want to do is to be able to find a way to do it a bit more quickly. So what I'm going to do is I'm just going to pull this away for a minute and go back to this diagram for a second. Because what I want to do now is I want to draw out these three, this, and this, as ions. So I have the lithium, this is an atom. I have this lithium here as an atom, and I have this oxygen here before it took those extra electrons. Let's see if I can be really precise with my rubber. It's really difficult to do. No, can't do it. Okay, so before I gained the extra electrons from the lithium, I would have had it as an atom. So if we're ignoring that one and that one, it would be an atom. What I'd like you to do is try and draw them as ions. So we'll have an ion of lithium here. We'll have an ion of lithium here, and we'll have an ion. Sorry, my pen is being a bit silly. Ion of oxygen we'll put over here. So what I'd like you to do is pause your screen and underneath each of these, draw them as ions. Okay, so I'm hoping that you've paused your screen and done the question. What you'll have is something that looks a bit like this. You have the first lithium like this, and it's got its 2 electrons from before, but it's lost its outer shell electron, and it has, of course, a positive charge. Why does it have a positive charge? Call out your answer to the screen on 3. Why does it have a positive charge? 1, 2, 3. I'm hoping you said because it's lost an electron, or you've added more detail to that and you've said because it's lost an electron which has a negative charge. We'll do exactly the same thing for this lithium over here. And now it's time to draw the ion of oxygen, which is often called the oxide ion. Again, you should have done this, so all you should be doing now is just checking that you got this correct and paying attention to what I'm doing. I've got my oxygen. Now oxygen we drew with dots, like so. And now it's got 2 crosses. It's got one from this lithium and one from that lithium. If we go back to our drawing, we can see that this cross goes to there and this cross goes to there. What charge does it have? Call out your answer to the screen on 3. What charge does it have? 1, 2, 3. I'm hoping that you said 2 minus or minus 2. Either is fine. Now what we do is we write these out. We can write these out as like a formula. So Li we would write like this. Li plus. We'll write Li plus like this as well. We would write O 2 minus like that too. Now what you should be able to notice is that here I've got 2 positive charges in total. So if I took that and I took that together, I would have 2 positives. And over here you can see I've got 2 negatives. Now broadly, the idea is that your number of positives needs to add up to your number of negatives. If you have a different number of each, then you've done something wrong. So when I said to you before, why could I not just use 1 atom of lithium? Well, if I only use 1 atom of lithium and I didn't have this whole thing over here, so if I took this whole thing away, I didn't have that, I would only have 1 positive, which does not work because then I'd have 1 positive but 2 negatives. So that does not work. So instead, I have to have both of these ions in order to give me the two positives. What I'd like you to do is pause your screen and copy this down. Make sure that your notes are perfect and that you've added all of this stuff. Pause your screen and make sure your notes are perfect. Okay, you should only be listening to me now if you've made those notes for yourself. And we go back to over here. Let's have a look first at sodium fluoride. So I'm going to write out sodium fluoride like this. Now, I look at the periodic table and I know that sodium is Na. And I know that fluoride comes from fluorine, which is F. What I always like to do is I like to write these as two columns, and I have my positive column and I have my negative column. And the metal is always in the positive, which means in the negative I always have my what. If the metal is in the positive, what do I have in my negatives? Call your answer to screen on 3. What do I have in my negative column? 1, 2, 3. Should have written, or said, sorry, non-metal goes over there. Now, I need to add the charges. So do you remember when we went back over here, we drew the formulae out with charges like this. So I need to do the same thing for sodium and fluorine. Now, sodium is in group what? Find your periodic table, call out your answer to screen on 3. What group is sodium in? 1, 2, 3. I'm hoping you said group 1, or alkaline metals. Now, the fact that it's in group 1 tells me something about its electrons and the electronic structure, and specifically, it tells me something about the outer shell. What does the fact that it's in group 1 tell me about the outer shell? Call out your answer on 3. What does the fact that it's in group 1 tell me about the outer shell? 1, 2, 3. It has 1 electron in the outer shell, is what I'm hoping you said. And therefore, when it loses that electron, just like with lithium before, it takes a positive charge. Now, fluorine will do a bit quicker because, again, I'm expecting you to be able to do this stuff very fast by now. Fluorine is in group 7. How many electrons does fluorine have in the outer shell? 1, 2, 3, 7. So 7 electrons in the outer shell for fluorine. Therefore, what does it need to do in terms of gaining or losing electrons? If fluorine has 7 electrons in the outer shell, so it had 7 electrons in the outer shell, 1, 2, 3, 4, 5, 6, 7. What does it need to do in terms of gaining or losing electrons? Call out your answer on 3. What does fluorine need to do in terms of gaining or losing electrons? 1, 2, 3. It needs to gain 1 electron, which means in turn that it will have what charge? What charge will there be on a fluoride ion? Call out your answer on 3. What charge will there be on a fluoride ion? 1, 2, 3, minus 1, just like that. Now, what I then like to do is I like to add up the positives and the negatives. So on this side, I've got 1 positive, and on this side, I've got 1 negative. Now, that means they are very, very happy indeed, because you remember I said the positives need to add up to the negatives. If I've got 1 positive here and I've got 1 negative there, happy days, nothing needs to be changed. So my formula here is NaF, just like that. Now, what you should notice, by the way, and I'll actually, I'm going to write that in blank just to be consistent throughout. So this was 1 positive and this was 1 negative. So we can just put these together and I'll write NaF. Now what you should notice is that when I've written out this, the ionic formula, you should see that there are no charges. We only use the charges when we're working out what the formula is. But once we've worked out what the formula is, we get rid of those charges completely. We don't write them into the formula. Let's have a go at sodium oxide. Sorry, black pen. Sodium oxide. So again, I've got my positive column, my negative column. Now sodium we know from before is Na+, and oxygen we also know from before is O2-, because we did that one about a second ago. Now, what I can see here is that I've got one positive, but I've got two negatives, which is no good. So all I do is I just add another thing into this positive column. So let's get rid of these. I'm going to add another thing into my positive column, Na+. I now have two pluses in my positive column, and I have two negatives in my negative column. Now remember, you might think, oh, hang on a second, I've got two here because I've got 1, 2. So that's why I have two here, but I've only got one here, so why is that not 1? No, it's because of the charge. So over here, I've got negative charge. Sorry, over here I've got two negative charges, which is why I've got two minuses down here. Over here I've got 1, 2 positive charges, which is why I've got two positives down here. Now, when I take these together, I need to write out my formula. My formula is not going to be NaO because I've got two of these. So I have to put a little 2 over there. Na2O because I've got two sodiums. Let's have a go at the last example here, which is sodium nitride. So my positive column, my negative column. Again, sodium is Na+. Nitrogen on your periodic table, you should be able to have a look now, is in group what? What group is nitrogen in? Call out your answer on 3. What group is nitrogen in? 1, 2, 3. 5. Very good. It's in group 5, which means it has 5 electrons in the outer shell, which means what charge will it take when it's an ion? What charge will nitrogen take when it's an ion? Think about it first. What charge will nitrogen take when it's an ion? Call out your answer on 3. 1, 2. Sorry, I'll go back and read the question again. Cheeky. What charge does nitrogen have when it's an ion? 1, 2, 3. I'm hoping you said 3 minus. N3 minus. You see, it's in group 5, which means it's got 5 electrons in the outer shell. It needs to gain 3, which gives it 3 negatives. Now, when I count these up, I've got 1 positive down here, and I've got 3 negatives over there, which leaves me with a problem, because these two numbers need to be the same. They need to add up. The number of positives needs to be the same as the number of negatives. So all I do is what? What can I do to make this happy? If I need to get the number of positives to equal the number of negatives, what can I do? Call out your answer to screen on 3. What can I do to make this happy? 1, 2, 3. I'm hoping you said add another couple of sodiums here, because now I have 3 plus over there, 3 minus over here. I'd like you to see if you can now work out the formula. By the way, this is what we said. This is the word that we used before. This is deducing. It means basically to work out, right? So can you deduce, can you work out the formula then of sodium nitrate? I'll let you think. What is the formula of sodium, sorry, not sodium nitrate, sodium nitride. What is the formula of sodium nitrate? I'll let you think. Nitride, I'll let you think. Okay, time to answer the question. What is the formula of sodium nitride? Call out your answer on 3. 1, 2, 3. I'm hoping you said Na3N, like that, sodium nitride. Because I've got 1, 2, 3 sodiums and 1 nitrogen. Cool. All right. What we'll do is, these are ones for you to try yourselves. Have a go at doing these on your own for me, please. You're going to pause the video and you're going to have a go at these questions. Pause the video now, please. Okay, you should only be watching the video now or listening to my voice if you've had a go at these. Now, these ones are dead straightforward. They're basically exactly the same as the previous ones that we did. So let's have a go at doing them together. Now, if you got like massively stuck and you have no idea what to do, then what I'd like you to do is watch while I go through the first example, then pause and have a go at the second answer yourself. Essentially, at any point where you think you can do some of these yourself, you should be pausing and doing them yourself. So potassium chloride, I've got my positive column, my negative column. I'm going to have a K plus and a Cl minus, which leaves me with 1 plus over here, 1 minus over there, which gives me KCl, like so. Potassium oxide, I've got my plus and my minus, I've got K plus and O2 minus. Now, obviously, that's no good. I'm going to need another K plus, and therefore, it's going to be, and that'll give me 2 pluses here and 2 minuses there, and that would be K2O. Potassium sulfide, I've got K plus and S2 minus. Now, that K is not happy, there needs to be another one. The positive column, rather, is not happy, so I need another one, which gives me 2 pluses, 2 minuses, K2S. What about magnesium fluoride? Okay, so this is the first metal we've done with a different charge. So I go to my positive column, my negative column. Magnesium is going to be Mg2+. If you got that wrong and you wrote Mg+, pause the video now, fix it all, and then press play when you're ready. Okay, so if you got it wrong, you should be pausing the video, fixing it, and going back. F is, of course, just F minus. So I've now got 2 positives and only 1 negative. So I'm going to need to add another one here, which should give me MgF2. And then finally, magnesium bromide is very, very similar. I've got my positive column, my negative column, Mg2+, Br minus. So I've got 2 positives here, but only 1 negative here. So I'm going to need to add another one there, Br minus. Then that becomes 2 minuses. And that will be Mg Br2. Actually, I should have made that clearer over there as well. Good. I'm hoping that you got all those right. If you didn't, then you need to go back to my worked examples from before, where we were doing these up here. They are very, very similar to each other and to the previous ones, so they should not have been particularly challenging for you. Okay, let's make it a bit harder, and we'll have a go at something like aluminium oxide. Now, by the way, if you're feeling brave, just go for it yourself. If you're feeling brave and you think you can do aluminium oxide by yourself, just go for it. Pause the video and just go for it. If you're like, I'm not 100% sure, I'd like to see how Sir does this, then keep watching. Aluminium is going to go into my positive column as Al. Now, what group is aluminium in? Find it in the periodic table. You should see this in group 3, which means it has a 3+ charge. Into my negative column, I'm going to put oxygen, O, and as we know, because we've done this about a zillion times now, O2 minus, like that. Now, this is a bit of a pain, right? Because I've got a 3+ and a 2 minus. So I know that I'm going to have more here, because if I've got, say, 3+ here and only 2 minuses there, I know I'm going to need to add another one here. So I'm going to make that O2 minus like that. But now I've got too many on this side. I know that these two numbers need to be the same. So how am I going to do that? Right. Well, let's say I add another Al3+. God, this is going crazy, isn't it? How much charge do I have over here? Call out the answer now to your screen. How much positive charge do I have over here? Call out the answer to your screen on 3. How much positive charge do I have? 1, 2, 3. 6 plus. 6 positive charges and only 4 negatives here. I'm sure you probably worked out what I can do to finish this off. Call out your answer to the screen. What can I do to finish this one off? 1, 2, 3. I can just add another O2 minus. And that will give me 6 minus. What I'd like you to do now is try and see if you can figure out the formula for aluminium oxide based on this. See if you can figure out or deduce the formula of aluminium oxide. You're going to call your answer on 3. What is the formula of aluminium oxide? 1, 2, 3. Al2O3. Because I've got 2 aluminiums and 3 oxygens. Crazy times. What I'd like you to do is have a go at these ones yourself, please. So as ever, if you don't bother doing these activities, you're wasting your time. You might as well just go off and watch some TV. I mean, don't do that. Don't go and watch TV. You should be just doing the activities. Pause the video, do the activities. Okay, you should only be listening to my voice if you have done these now. Aluminium sulfide in the positive. So I'll do question 1 up here. Actually, you know what? Just to make it super duper clear, I'm going to rewrite. So aluminium sulfide is going to go over here. So we know we have a positive column and a negative column. Al3+, S2-. So I'm going to have to add in exactly the same way that I did last time. So to get 6 minuses over here, 6 positives over there, Al2, S3. And again, you notice that there are no charges here. I haven't written S6, because even though I've got 6 negative charges, I've only got 3 ions of sulfur. My aluminiums, I've got 2 of them, because even though I've got 6 positive charges, that's only 2 aluminium ions. Next up is calcium nitride. I've got my positive column, my negative column, Ca 2 plus, and N is 3 minus. We did this one a bit earlier on. So here I need to do almost the reverse of what I did in the last one. And I'll end up with 6 positives here, 6 negatives there, and that will be Ca3N2. Final one, boron oxide. Boron is in group 3, so it's going to go in my positive column as B3 plus. Oxide is O2 minus. Had another one here, had another one here, had another one here. Now I've got 6 pluses here, 6 minuses there, and I've got B2O3. If you got all those correct, bravo, good job. If you made like a small mistake somewhere here or there, that's absolutely fine, you can carry on. If you have made like a massive mistake and you've got the same error in each one, then you should probably pause the video, go back, cover your paper, and try each one again from scratch until you can figure them out and get them right. It does get a bit more complicated with things called, I'm not going to actually turn to that screen yet because I don't want you to get distracted, with things called compound ions. So far we've looked at where each ion is basically one element. So you've got an Al3 plus and that's the ion and that's it. And then you've got an S2 minus and that's the ion and that's it. Unfortunately, it does get a bit more complicated because there are ions which exist as 2 atoms joined together. So for example, OH minus. Right? It's an oxygen and a hydrogen bonded together, and overall, it's got a negative charge. That's going to make life a bit more complicated. I've also got things like the sulfate ion, so SO4, 2 minus. Sorry, make that clearer. That's SO4, 2 minus, which essentially means I've got a sulfur and 1, 2, 3, 4 oxygens. And all of that has a double negative charge. What I've done is I've summarized them into a table, and I'm going to put the table on your screen. You can just have a look at it for a second. And I'm going to ask you to listen to my voice again, please. These are the 5 compound or molecular ions that you're going to learn about. And you do need to know them off by heart, but for the minute, I'd like you to just write down this table into your book or piece of paper because you're going to need it as a reference. So pause the video and get that down. Okay, you should only be playing the video if you've got that down now. Like if you haven't got it down, you're simply not going to be able to do the rest of the questions. So make sure you've got that. And let's do some worked examples. We'll start with sodium hydroxide. So we'll do calcium sulfate and ammonium fluoride. Okay, so sodium hydroxide, I've got my positive column and my negative column. Do exactly the same thing. In my positive column, I've got Na. And I know that it's Na plus. Hydroxide. Well, I go back to my table and I can see over here that it's OH minus. Like that. Which means that I've got 1 positive over there and I've got 1 negative there, which means everybody's happy. And I just write it out as NaOH. We almost always write we actually always write the positive ion goes first. And again, you notice I haven't written any charges in. It's just very simple, done. So if you're at NaOH minus or Na plus OH minus, that would be wrong. Don't do that. Okay, we don't write the charges in once we've deduced the formula. Calcium sulfate, positive, negative. Ca is 2 plus, as we know from before. SO4, oh, I go back to my table. Sulfate ion is SO4 2 minus. Don't confuse this with sulfide. like I accidentally did earlier on. This is sulfate, not sulfide. I've got 2 pluses, 2 minuses, so that's also very happy. See if you can do ammonium fluoride yourself. Ammonium fluoride yourself. Pause the screen and do that one yourself. Okay, you should only be listening to me now if you've done ammonium fluoride yourself. So you have your positive column and your negative column. Ammonium, what's ammonium? Well, I go back here. Here's the ammonium ion, NH4+. So let's go back. Fluoride is F-, and we've done that one before. 1 plus over there, 1 minus over there. Don't be confused and say, oh, well, it's got 4 there, so it must be 4 pluses. No, that means it's got 4 hydrogens, but overall there's only 1 positive charge. Like when we looked at the sulfate, go away. Like when we looked at the sulfate, right? We said it's SO4 2 minus. What that means is it's got 1, 2, 3, 4 oxygens, and overall the charge is 2 minus. Yep. So that's all very happy, which means I can just write down my formula as NH4F. Easy peasy, lemon squeezy. Next up. Okay, so there's the table again. What I'd like you to do for yourselves is have a go at these ones for me, please. Have a go at these ones. Okay, so I'm not going to go over each one of these in detail now because you've done many of them already. So lithium hydroxide is just going to be LiOH. These ones are really straightforward. Calcium carbonate, CaCO3. Sodium nitrate, NaNO3. And again, not to be confused with nitride. This is nitrate, NaNO3. Ammonium bromide, NH4Br. Ammonium hydroxide, NH4OH, and barium sulfate. Barium is in group 2, which means it's got 2 electrons in the outer shell, so it forms a 2+ ion. Sulfate forms a 2- ion, so BaSO4. God, that's easy, isn't it? Except for the fact it gets a bit more complicated. Let me show you how. Okay. Let's try these ones. We'll start with sodium sulfate. Now, by the way, if you're feeling confident, you think you can do this one yourself, just pause the video and go for it. If you're feeling less confident, then just pay attention. We'll go over it together. So sodium sulfate will look a bit like this. You've got your positive column and your negative column. Here's my Na+, and my sulfate is SO4 2-, and again, that's just straight in the table, SO4 2- for the sulfate. I've got 1+ over here, but 2 minuses over there, which is no good. So I'm going to need to add another plus over there, which will give me 1+. Sorry, give me 2+. Taken together, they are now adding up. They're now happy. So I'll have Na 2N, because I've got 2 NAs over there. Joy. Calcium hydroxides. This is where things get a bit more complicated again. Calcium hydroxide. Well, calcium, I've got my positive column, my negative column. Calcium is Ca2+, and hydroxide, as we know, is OH-. When we go back to our table, we can see hydroxide ion over here, OH-. Good. Now that gives me 2+ over there, but only 1- over there, which is not good. So obviously, I need to do what? Call out your answer to the screen on 3. What do I need to do to make this happy? 1, 2, 3. I'm hoping you said add one of these, add a hydroxide ion, which means I now have 2-. How do I write that? Oh, that's a bit complicated. I write Ca, and then in brackets, I do OH2. Not, this is important, I don't write CaO2H2. You don't really, I'm not going to go into crazy detail about why this is wrong, but basically the reason why it's wrong is because what CaOH2 is I've got a Ca 2+ like this, and 1 OH- like that, and another OH- like that. That's what this means. That's what this means. That's what that is. This would be something more like where I have a Ca2+ and like an O2 minus, and then another O2 minus, and then maybe like a O2, sorry, not 2 minus down there. Make that a bit clearer, sorry. Like an O2 minus like that, and an H plus like that, and an H plus like that, which is wrong. The idea is that this OH is bonded, and this OH is bonded, and then they too are bonded to the central positive ion. I'm not going to go into much more detail on that because you don't really need to know. All you need to know is that the key thing is to add brackets and not to just fiddle around with those little numbers and do it like that. All right, the last one there was ammonium carbonate. What I'd like you to do is have a go at that one by yourself, please. So you're going to do ammonium carbonate by yourself. You're going to pause the video and do that one by yourself. Okay, so you should only be listening to my voice if you've done ammonium carbonate now. So ammonium, as we know, is NH4+, carbonate CO3, 2 minus. How do I know those? Well, NH4+, carbonate CO3, 2 minus, which leaves me with 1 plus over there and 2 minus over there, which is obviously no good. So I'll add another one of these here, and that will give me 2 plus. And now I've got 2 of these, one of those. So my answer is NH4, 2, CO3. And of course, not N2H8. It's this NH4 in brackets with little 2 next to it. Here are some for you to try yourselves. Use your table to have a go at doing these ones for yourself. Pause the video, do these ones for yourself, please. You should only be listening to my voice if you have done these now. I'm not going to go over each one in detail. I'm just going to write the answers. First one is MgNO3, 2. That's because magnesium is 2 plus, NO3 is 1 minus. Barium hydroxide, or barium is 2 plus again. So barium hydroxide is going to be BaOH2 because OH is 1 minus. Lithium carbonate is going to be Li2CO3 because I've got 1 positive on the lithium and 2 negatives on the carbonate. Magnesium sulfate, that's just going to be happy, MgSO4. Aluminium nitrate, well, if aluminium is 3 plus and nitrate is 1 minus, I'm going to have 3 of these. Aluminium sulfate, well, if aluminium is 3 plus and sulfate is 2 minus, I need to have 2 aluminiums to bring it up to 6 plus, and 3 sulfates to bring it up to 6 minus. Finally, ammonium carbonate, NH4, 2, CO3. I'm hoping you didn't find those too challenging, given that we took it really slow and built up our examples over time. If you really massively struggle with those, then I suggest you go back in the video to this section where we were going over these again and try those with a blank sheet of paper until you can get them right. For now, that's the end of this video, and a reminder that this is the first video if you're studying reactivity of metals, acids and alkalis, or electrolysis. Thank you again for listening, and I will see you next time.